Determine if the following lines are parallel, perpendicular, or neither. And we're given two equations of the line. We have 3x minus 2y equals 16, and 2x plus 3y equals 16. And let's quickly recall that two lines are parallel if their slopes are equal. So if the slope of the first line equals the slope of the second line, we say our two lines are parallel. And we say that two lines are perpendicular if the product of their slopes is -1. So if the slope of the first line multiplied by the slope of the second line equals -1. And then from here, we can see that an alternative way to think about it is that if the slopes are negative reciprocals of each other. So these are the two things that we're looking for in these given lines here. So in order to check if these lines are parallel, perpendicular, or neither, we need to rewrite each line in their slope-intercept form. And the reason we're rewriting them in their slope-intercept form is because this is a nice, easy way to identify the slope here, that m value. So let's see, we'll label these. This is line number 1 and line number 2. So working with the first line, we have 3x minus 2y is equal to 16, and we want to solve for y. So what I'm going to do, because I'm noticing here that this y value is negative, I'm just going to rewrite this in the equivalent form and say that this is 16 is equal to 3x minus 2y. So now when I solve for y, it will become positive, so I can maintain it on the left-hand side. So I'm going to add a 2y to both sides of this expression. And we're going to want to subtract 16 from both sides of the equation here as well. Right, so we have minus 2y plus 2y combines to 0. And then positive 16 minus 16 will combine to 0, leaving us with 2y is equal to 3x minus 16. And then to isolate y here, we'll divide both sides of our equation by 2. So we have some nice simplification. We have 2 divided by 2 is 1. We can even see here as well that 2 goes into 16 8 times. So this leaves us with a simplified form of the line, or the slope-intercept form. Y is equal to 3/2 x minus 8. So this is line number 1, and it has a slope of 3/2. So now we want to go ahead and do the same thing for our second line before we can compare them. So our second line, line 2, is 2x plus 3y is equal to 16, and we want to solve for y. So we can rewrite it in its slope-intercept form. So I'm going to go ahead here and subtract 2x from both sides of the expression. Right, so positive 2x minus 2x combines to 0, leaving us with 3y is equal to minus 2x plus 16. And then to isolate y here, we will divide both sides of the equation by 3. So we have 3 divided by 3 is 1. And I have y is equal to negative 2/3 times x plus 16/3. And this is our second line. So now we're ready to go ahead and to compare the slopes. So again, we identified that the slope of the first line is 3/2. So m sub 1 is 3/2. And then the slope of the second line here is minus 2/3. So we can certainly see that they're not parallel here. These are not equivalent slopes. But they almost look like negative reciprocals of each other. So let's go ahead and we'll check if they're perpendicular. So again, a nice way to check that is to use the initial formula. Does the slope, or does the product of the slope of the first line times the slope of the second line, does this equal -1? And we have 3/2 multiplied by minus 2/3, which, yes, it does equal -1. So we can say that therefore the lines are perpendicular.